units that you need to concentrate, right? Revision session. So here, in the theoretically, I can say that first 4 units, as it was what we have been gone through in the data structures also, right? First 4 units and rest other 2 units, sorry, 3 units, 5, 6, 7. If these up to 7 units, if you are preparing, theoretically, definitely you can able to answer all the questions. Okay, so up to 4, where compulsory questions will be there, and depending on the choice, where you can able to study a 5, 6, 7 unit also. Actually, where we have been submitted 2 to 3 sets of question paper. We don't know which question paper where they'll be selecting for you. So better my choice, what I will say, up to 8 units, if you are preparing, that is more than sufficient for writing the descriptive answers, right? And while writing the descriptive answers, I've been seeing in the last examination also, where some of them are trying to copy from the website, and as it is, you are writing. As it is, you are writing. So if you're writing as it is, it easily we can able to sense that you have been copied, right? So make sure that is so. When you are doing such type of things, at least somewhere you need to apply your knowledge also there. It is not that it's just simply you're copying and writing as it is. Most of the if the examples are being given in some of the websites, their website names, and as it is, you people are writing. Many are not saying all, many of them. So at least in such areas you should be careful while writing. Some little bit sense that should be applied while writing the examinations, right? And theoretically, if the questions are being asked, make sure whatever the based on the questions, right? So based on the questions, if the question consisting of some subheadings or something like that, so list out those things and write one after the other. And as you know that simply like a story type, many of them used to write because it is a theoretical subject. So many of them are used to write as an story, like without any paragraph, without anything, like starting to ending, 2 pages, 3 pages they used to write. So it makes sense there itself. We can say, we can think or analyze that something has been written. Okay. So make sure there should be some points. There should be some points, and some of them are writing within one page with its very small font you are taking, and you are writing within one page the entire thing. What is the use of writing like that? So whether then we need to zoom that text what you have been written, and then we need to evaluate all those things that's going to be happening. Okay. So my suggestion is, make it clear whatever the thing that you are writing, whatever the thing that you are writing, make it much more clearly and better way of submitting the things. And when you are submitting also, when you are taking a snapshot, you are taking the snapshot somewhere, the paper will be elsewhere, and you'll be taking from very far where you'll be taking these snaps. So which means sometimes it may not be readable also without checking those things and all directly you are uploading. Right there again, you'll be losing the marks, even though you have been written, so you'll be losing the marks there also. So make sure, see, these are the some of the small things that should be learned when you are writing when you're writing and uploading the marks answer sheets. Okay, that is one. And as already you have been practiced MCQ questions, right? Already you have been practiced the MCQ questions. These MCQ questions will be from all the units. It is not actually it is not restricted for 1 unit or for 10 units or something like that. It has been these MCQs will be taken from all the units, and these even though it has been taken from different 15 units. So here where I can say out of these questions, what we have been prepared and given. So the system will be randomly, it is going to be selecting. It is not like that first question, whatever you are having, the other person also will be having this first question, the same thing. So the system is going to be taking randomly and it is going to be distributed to all the students. So where, and also where you may not be having only the 40 or 50 questions as an MCQs. Okay, so don't assume that 50 questions have been randomly, it has been selected and it has been sent. Okay, so here we have around 300 to 400 MCQ questions of entire units. Okay, so out of these 400 MCQs, where you may be getting the questions is going to be generated for each and every student separately. Okay, that is one more thing that you should know, because since when you are learning the trying to learn the descriptive answers, so as I said, 8 units there. So many of them may be thinking that if I'm studying up to 8th unit, entire descriptive and MCQ, that is more than enough. Like that you may be assuming. No. So MCQs will be covering all the 15 units, where you need to go through all the entire syllabus. So descriptive, where you'll be having 8 up to 8 units you can, if you're studying, that is more than enough. So let us have some of the questions, some of the MCQ questions, right? And as well as when you are what I can say, when you are going for descriptive questions. So as I said, if you have a diagram and with the help of diagram you explain something, right? So when you have like that, yes, yeah, 1 to 8, first unit to 8 unit, if you are going to, that is more than enough. So, so study those things, but especially for descriptive and for MCQs, you need to go through all the units. Okay, and as I said, if in the questions somewhere they might have been asked some diagram explain with an example, with any diagram or something like that. So make sure write the diagram, identify the name those components which is being used in that, and then you start writing one after the other. It is not that namesake something there you will be writing. So, because all these things have been observed that without seeing without naming properly and all, just simply namesake they might have been written. You people, many of them have been written. Okay, so don't do like that. See, even though you know those concepts, simply you'll be losing the marks. Okay, so make sure write properly. And as I said, when you're taking a step, when you're considering, when you're having any subheadings and all, so make sure list out those subheadings and take out one after the other. Then you try to write what exactly it is. Okay, and suppose if they give any problems oriented, like you have in the cryptography related concept, something where you're having, right? Like RSA algorithms or Diffie-Hellman key exchange or SHAs, like that you're having, right? So make sure the values, try to practice those type of questions that you may be expecting. Okay? That is what relating to descriptive. And when you're coming to the MCQ questions, I think already you people have been practiced the MCQ questions, how it is going to be like, right? Let us have some more discussions with some of the questions of MCQ questions. Okay. So here, like for example, we're taking RC4 belongs to which of the following category of cipher? So RC4 belongs to which of the following type of, which of the category of cipher? So where you may be having something like block cipher, code cipher, text cipher, and string cipher. So which cipher it belongs to? This RC4. Yes, no, it is block cipher. Rani, it is string cipher. Any other answers? Akshita, string cipher. Message you can send in a group, let others also will see. No problem. If it is wrong, also nothing. Anyhow, I'll tell the answers for that. Just guess out, or since you have been gone through the sessions and materials, just have an idea. So how many types of cycles you are having? You are having two types of cycles, right? But in the options, you may be having like different, because you need to have four different options, right? So only block cipher, code cipher, text cipher, and stream ciphers. Stream cipher. It is a stream cipher. Yes. So RC4 is a stream cipher, because you have like RC4 and A5 algorithms you are having, like a stream cipher, right? So according to the syllabus, you don't have A5, so you are having RC4 as an stream cipher, right? So when you are taking a stream cipher, as we know that, it is going to be processed byte. It is going to process byte by byte. So only we say it is a streams. When you're taking a block cipher, so a group of bits, like as we studied, as we have been gone through, like a DS algorithm, AES algorithm, and so on, right? So 64 bit as one block. Okay. So here, the blocks, it is going to be taken in streams. Right. And one more question, consider the following, like substitution bytes, row shifts, mixed columns, add round key belongs to which of the following algorithm? These are the steps which are these are some of the steps which is going to be following by which of these algorithm. So substitution bytes, row shift, shift rows, mixed column, and add round key is again identified in which of the following algorithm. That is, options are, that is rail fence cipher, data encryption standard, advanced encryption standard, international data encryption algorithm. Yes. Understood now the question what I asked? So these are the some of the steps that you are having. These steps are being followed in which of the following algorithm? Yes, Reni, it is right. So what are those steps? Substitution bytes, row, shift rows, mixed columns, and add round key have been identified in which of the following algorithm? That is rail fence cipher, data encryption standard, advanced encryption standard, international data encryption algorithm, IDEA. No idea? Which of the algorithm? Which of the algorithm where we have these are the different type of steps are going to be followed in order to encrypt or decrypt? Okay, Akshita. Yes. It is AES algorithm, advanced encryption standard. Advanced encryption standard, where you have these are the four different each and every round consisting of these substitution bytes, row shifts, mixed column, and add round key. Right? So these are the four different operations steps which is going to be taken place in each and every one. But at the last round, where add round key will not be there. Add round where key step will not be there in the round function. Right? Let's recall those things in the AES algorithm where you are having these things. And the other one, in RC4 algorithm, the master key is being used to construct state vector by using how many bytes? In RC4 algorithm, the master key is being used to construct state vector by using how many bytes? 112 bytes, 56 bytes, 100 bytes, 256 bytes. Yes. So see, I can say, for example, the key size, what you're having, something like Jain, something, JAIN you are having. So we need to create a master key for it. So in order to create that master key, so you need to fill out the entire vector, entire state vector you need to fill out. So in order to fill that, how many bytes are going to be used? What is the length of the state vector?
8.
8-bit. No? Options are 112, 56, 100, 256 bytes. 112 bytes, 56 bytes, 100 bytes, 256 bytes. So where this one, I can say, when you see the diagram of that RC4 algorithm diagram, when you're getting in the RC4 algorithm diagram, so where in the first one you'll be having state vector, second array you are having temporary, third you will be having like a key. You'll be taking these three. So with the help of the key, you'll be generating. You can't have only four characters or 4 bytes or something like that. So in order to fill all those things, each and every time where Jane like that, you'll be filling the entire array. So what is that size? How many bytes it is going to fill like that? Himanshu? It is a 256 bytes. It is a 256 bytes. Okay. And the other one, how many number of bytes are used to encrypt at a time in the stream cipher? At a time. At a time, how many number of bytes are used to encrypt at a time in stream cipher? Stream cipher means what? So character by character. Correct? No? Just the reverse engineering you can make. So options, you are having like 2 bytes, 3 bytes, 4 bytes, 1 byte. Yes. Yes. It is 1 byte, a character by character. Correct? A character by character. Just to recall the stream generator diagram, you can see how it is going to be processing. There you can find 8 bits. 8 bits is nothing but 1 byte it is going to be taken to encrypt or decrypt the data. Okay? And the other one, you can see, which of the following key exchange algorithm, that eliminates requirement for third-party verification. Instead, it may be directly verified between the parties. So whenever you want to exchange the key, you need to transmit through the third party. You need to transmit through the third party. Correct? No? So here we have one of the algorithm which is going to be eliminating the requirement of third party. Directly the data will be sent to the parties and they are going to be verifying the key. Options are RSA. Is it? Yes, correct. So the options are RSA, BES, AES, and Diffie-Hellman. RSA, DES, AES, Diffie-Hellman. So understood, no? The question what I asked? Shita? Yes. Shita. So see when you see one way I can say when you are reading the question, if you are not able to identify answers directly, check the options. Reverse engineering you can make. RSA algorithm. Definitely we require public key and private key. Yes, Nazim Supiya, it is right. Right? So here RSA we require public key and private key. Correct? No? And DES, definitely a secret key is going to be used so that it has been sent to some other party. AES, again, it is also asymmetric. So where it is going to be used, the key is shared key is going to be used between the parties, right? Diffie-Hellman, the name itself it is there in the question. So if these three are you are perfect, you know that it is wrong, then the leftover it is Diffie-Hellman only. That is what reverse engineering you can make, right? So which of the following key exchange algorithm that eliminates the requirement for third-party verification? Third-party verification. Instead, it may be directly verified between the parties. Directly, no way. RSA, DES, AES is not going to be verified directly, definitely. So the other option you are having left over it is Diffie-Hellman. Because, yes, correct. Right. So because in the Diffie-Hellman, definitely we are going to be sharing the values and with the help of the Diffie-Hellman algorithm technique, where they generate by themselves the key. Based on that, the encryption and decryption is going to be taking place. Correct? No, you are not going to be explicitly, you are not going to be transmitting the key from 1 to 1. Right? Now, the next one, it is, you can see, which of the following key is kept secret in RSA algorithm? Which of the following key is being kept secret in RSA algorithm? So RSA algorithm is asymmetric, right? Asymmetric means definitely you'll be having two keys. Definitely you'll be having two keys, right? So the options are you are having public key, session key, two key, private key.
Private key.
Yes. Because why private key? Because each and every user generates two keys, private key and public key. So public key is going to be broadcasted to everyone. So that this public key will be available in each and every system which has been connected to that network. So private key has been kept as a secret. Whenever they are trying to transmit, they use the public key and they are going to be encrypting. Once data has been received to the actual receiver, so he uses private key and he is going to be decrypted. So only private key has been kept secret. This private key will not be available to any of the users. Only the owner of that system will be having the private key. Okay. In public key encryption, how many number of keys are used for encryption or decryption? Encryption or decryption. In public key encryption, how many number of keys are used for encryption or decryption?
Options?
1, 2, 3, 4. 1, 2, 3, 4. Options are
One.
1, John. They're saying it is 1. And some of them are saying it is 2. So how it is? Can you anyone say that? Some of them are saying 2, and some of them are saying it is 1.
So one key will be used for encrypting and another key will be used for decrypting.
Definitely, Himanshu. Definitely. So there is what's only what is a public key encryption. Read the name. Read the name. Correct? No? So because it is in public key encryption. In public key encryption, the names you know that public key encryption, asymmetric key encryption, two keys encryptions, all those are same, right? So in public key encryption, definitely they use two keys because one of the key has been used for encryption or decryption. They may be using private key or public key to encrypt and decrypt. Once it reaches to the receiver, he will be using his own key. When they are encrypting, they are using different key. When they are decrypting, they are using the different key. So totally how many number of keys are being used? Two keys are being used. Okay. Yeah. The next one it is which of the following method ensures that received communications are genuine and have not been tampered? Which of the following method ensures that received communications are genuine and have not been tampered? Options are confidentiality, availability, security, message authentication. That is what. See, sometimes the answers, more than one answer, it may be suitable to this. For example, you can say that, right? At that time, go as I said, reverse order. Reverse order. Nozin Sophia. Go for reverse order. Based on the options, you decide which is right. Confidentiality, availability, security, message authentication. Really? It is wrong? Yes. Nozin Sophia. It is right. Now it is right. Before what you have said, it is wrong. Now you have been altered. Yes. Yes. That is what. See, of course, what if the options are being given there, what you have been saying, then you can say it is right. Based on the options, you can see. So, confidentiality, availability, security, message authentication. So, it is a message authentication. Because whether it has been tampered or not, how to identify once the receiver.
Integrity.
Yes, yeah, integrity, data integrity, where you are going to be checking. That is done, data integrity, where you will be checking the message authentication. You have seen the algorithms, message authentications related algorithms, right? So, where along with the data, the MAC is going to be attached to it and it is going to be transferred. Once the receiver receives actual message and the received MAC is going to be compared. If both are same, there is no changes have been done. The received data has not been tampered. If changes have been there, then definitely the MAC which is being sent along with the data and the MAC which is being generated by the receiver will be different. If both are different, definitely the message has been tampered. Right? Yes. The other one, which of the following code used to protect data integrity? Sorry, which of the following code used to protect the integrity of a piece of data or media to detect changes and alterations to any part of the message? Options are ASE, DS algorithm, RAS, and message digest. Is there anything like, see, now you are getting confusion with what is that ASE, DS, RSA. Is there anything like ASE? Reverse engineering. You make it reverse engineering. Let me read once again the question. Which of the following code is used to protect the integrity? Integrity is nothing but data integrity. Okay, integrity of a piece of data or media to detect changes and alterations of any part of message. Yes, Renu. Very good. Correct. So is there anything like ASE? Nothing like that. DS algorithm, it is an algorithm which is used for encryption, not for the data integrity. RAS, is there anything like that? Nothing. Message digest, what is that message digest? Whether can we find out with the help of this message digest data integrity? Yes, 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 Supriyan. Very good. Yeah, correct. So this message digest, when you see this message digest, there's just you need to recall the hash functions there. Hash functions you need to recall. So to any fixed length of data, any variable length of data, a fixed length of hash function is going to be generated, right? Along with that hash, the other way we can say it is a message digest. So this hash is going to be sent along with the data, as we have seen the message authentication. So already we have been gone through what is the difference between the hash message digest and message authentication. Both are used to find the data integrity only. But there you will not be using the key. Here you will be using along with the key. You will be identifying the you are going to be encrypting along with the key where you are going to be encrypting, and then you will be attaching this MD message digest to the data and you will be transmitting. Okay. So here the answer is message digest. The next one, it is, which of the following value HMAC use as iPad? So HMAC is one of the technique, right? Hash message authentication code, where they are using as an iPad to provide security, where they are going to be using the iPad bits. So like they have been given the sequence of bits like 0, 1, 1, 0, 1, 1, 0, something like that. So these bits are fixed. These bits are fixed. Okay. So whenever you are using the iPad bits will be as it is. The iPad bits will be as it is. So where they'll be giving different sequence of bits that you need to find out which of the following bits belongs to the iPad of HMAC. The sequence that you need to find out. Okay. And the other one, that sequence of bits, instead of reading, you can just go through. So where you are having HMAC users and iPad as well as OPAD also. Input pad and output pad also there where they'll be using. So they'll be in the options where they'll be including iPad bits as well as OPAD bits and some other extra bits, combinations of bits where they'll be giving. So you need to identify the sequence of bits, 8 bits where they've been given in each and every option. So you need to identify which of these bits are being used as an iPad. Okay. So as I said, now it is an iPad. So the other question you may find that OPAD, read that. So what are the bit sequence of OPAD which is being used in the HMAC? What are the bits which is being used in iPad in an HMAC? So that will be knowing this. And you can see these options are data which is there in the SLM also. Okay. The next one, identify the input size of the hash function. Identify the input size of the hash function. One for option 1, it is 512 bits, 1024 bits, 2048 bits, and variable length. So identify the input size of the hash function, which means what is the size of the input which has been given for an hash function. Where options are 512 bits, 512 bytes, 1024 bytes, 2048 bytes, and variable length. Yes, Akshita. Yes. What is the input? So as you have seen in the RC4 algorithm, 8 bits. Correct? No? If you're taking DS algorithm, 64 bit as an input. Similarly, yes, okay, right? Similarly, for hash function, what is the input size? Is there any fixed size or constant? Only this much only we need to be. Whatever the data we are having, we are according to that way we can able to give and how it is. Sure. Yes, based on the file. Very good. Any other options? So where it is a variable size of input is being given. Variable size of input is going to be given. So based on that question itself, suppose what will be the output size of any hash function? So now you said it is the input size of a hash function. The options are 41, 2048 and variable length. And many of them said it is variable length, which means the input is being given to the hash function as variable length. Right? Now, what will be the output of that? Since you are giving a variable length of an input, what will be the output of the hash function? Really? It is wrong.
Variable length.
Again, a variable length. will be available. Okay. It will be fixed. Any other answers? Rennie, you said it is 20 bytes. Fixed. Namrata? Yeah. It is a fixed length. It is a fixed length. Okay. So the input can be given in any variable size of input can be given. It has not been fixed so that whatever based on the file, the input can be a variable, and the output will be always the fixed size of output is going to be generated in the hash function. Okay. Yes, it is a fixed length. The next question you can see the result of a cryptographic data transmission that, when properly implemented, provides a means for validating origin authentication and data integrity, signature, non-repudiation is identified with what? So these are the things which is going to be. Let me read once again. The result of a cryptographic data transformation that, when properly implemented, provides a means for validating origin authenticity and data integrity and signature and non-repudiation is been identified. Options are public key. See the options. Okay. Options are public key infrastructure, repudiation, security, digital signature. If you find something from the question here, it is tricky, then go for reverse engineering. That is what I said. Go for reverse engineering. Definitely you can do it. Yes, Himanshu, it is right. Options are public key infrastructure, repudiation, security, and digital signature. See, with the help of two options, immediately we can able to guess what it is. One, it is validating origin authenticity. Okay. We are going to be identifying who is the actual person, right?
Digital signature.
Yes, John. Right. It is digital signature. And another, it is we are having data integrity. That is one more. And signature. The name itself, in the question itself, you can find signature. Where you are going to be finding, whether in public infrastructure, whether we have non-repudiation you are having, or security you are having. No, in these three options you don't find. Only the digital signature. These things are going to be implemented. Right? Yeah. The next one, it is, and as I said, make sure when you are learning the secure hash function related unit, where you find one table. So how many bytes, what is the block size, all those things. Make sure by heart those things. It becomes very easy when you're writing this MCQs especially. Okay. How many number of round computation steps in the SHA1 algorithm? How many number of round computation steps you're having in SHA1 algorithm? You're having options are 170 rounds, 180 rounds, 200 rounds, 80 rounds. Yes. So the table, if you find, then definitely you can able to answer these type of questions. Yes, correct. So how many number of round computations in the SHA1 algorithm? What is that? SHA means what? SHA means what? Yes. SHA. Yes, Namrata. Correct. Yeah. secure hash algorithm. Correct. So in the secure hash algorithm in SHA-1, how many round computations will be taking place? Yes, correct. Right is right. So where it is going to be taking 80 rounds. 80 rounds. It is going to be taking each and every time. You can see 20 inputs have been given each and every round wise when you're taking. So it is going to be taking 80 rounds. It is going to be taking 80 steps. Computation steps it is going to be taking 80. Okay. Then the next one it is identify the maximum length of message that can be taken by SHA 512. So on I said, learn the table, know the table. Identify the maximum length of message. What is the maximum length of message that can be taken by SHA 512? Options are 2 to the power of 50, 2 to the power of 75, 2 to the power of 64, 2 to the power of 128. Maximum length of a message that can be taken by SHA 512. Here options are 2 to the power of 128, 2 to the power of 64, 2 to the power of 75, 2 to the power of 50. Yes, Namrata, it is right. Yes, really, it is right. Yes, it is wrong. It is the input, maximum size of input can be taken as 2 to the power of 128. 2 to the power of 128, yes. It is not 64 because 50 and 75 nowhere have been studied. Just like that also you can think 50 and 60, 75 nowhere you have been gone through. And 64 you have seen in the DS algorithm. 128. Just the leftover it is 128. So that you can at least something you can able to this. And the other one where you have extensions to the X.509 certificates were added in which version? So where you have 3 different versions, right? 3 different versions are there. In which version that extension field have been added to the X.509 certificate? Version 1, version 2, version 4, version 3. Yes. Extensions to the X.509. You can't read X.509. It is an X.509. Yes, X.509 certificate have been added in which version? Version 1, 2, 3, 4. It's been added. And so then you need to learn those different versions that you need to learn. So version 1, what are the different fields that you are having? Version 2, what are the extra fields which is being added? That X.509 certificate you will be having. So that image, if you are knowing, then you can download that image itself directly. Once you know that image, immediately you can able to answer that. Okay. It is an version 3. Yes, it is version 3. Right? And the next one, it is the stored cookie which contains all your personal data about that website can be stolen away by attackers using which? The stored cookies which contains all your personal data about that website can be stolen away by attackers by using which? Antivirus, sniffing, website defacing, malware.
Malware.
malware. It is a malware. So these are the where about your personal data about that website can be stolen by attacker. That is being with the help of malware, they can able to steal all this data. Okay. So the other one it is which protocol is being used for sending and delivering from client to server in email. Client to server in email. Options are super. HTTP, POP, HTTPS, SMTP. SMTP. So again, here you may find the other question also. Whenever you are delivering the messages from server to the client in email, server to the client email, which protocol is being used? Here, which protocol is being used for sending and delivering from client to server in email? Okay. Now, if they want to deliver the mails from server to the client, which protocol is going to be used? Assume that the same options: HTTP, SMTP, HTTPS, and POP.
SMTP.
SMTP. Sure, SMTP. I think it is no. It is POP. So from client to server, when you are sending client to server, because you will not be directly sending from source to destination, right? You will be sending via server. When you are sending through the server via server, of client to server, where it is going to be using SMTP protocol, and server to the client, where they'll be using the POP protocol. So where you're having your POP3 usually. Now the version 1, 2, 3 are the versions. POP3 protocol, post office protocol is going to be used from server to the client when it is delivering the messages. Okay. Yeah. And the next one, what is domain name system, DNS? What is DNS? Domain name system. So options: it is a directory, not a lookup service that translates the host name into numerical address on the internet. First option. Second option, it can be shared any IP address. It cannot be shared any IP address. Third option, it works as message transfer agent. Fourth option, it is a directory lookup service that translates a host's name into numerical address on the internet. Option 4, option 4, option 5, 3, mention. Option 4, yeah. So DNS, because whatever you are typing, for example, you are typing some Google or whatever. Yeah, okay, no problem. So when you are typing something and when you are searching in the URL, so with the help of names, you will be searching. If you are searching through names, whether it is going to be transmitted and searched as it is, no. With the help of DNS, it is going to be converting into IP address. That is what numerical address. IP address, based on that, it is going to be fetching the information. That IP address is going to be sent to this client. Through that, where it is going to be sending to the so and so server, and it is going to be fetching the data. Right? Because when you are typing any name, it is not going to be searching with the help of that particular name. It is not going to be searching with the help of that particular name. Okay? With the help of IP address, it is going to be searching. Right. The next one, ESP. does not provide which of these features? ESP. You are having ASP and ESP. Just recall that. ESP and ASP. So ESP does not provide which of these features? Features. One it is first option, source authentication. Second option, data integrity. Third option, privacy. Fourth option, error control. So if you're getting a little bit confusion, go for reverse ordering. No connection. ESP. You are having the diagram also. ESP, ASP. In between you are having DOI. Just recall that diagram. And ESP, again it is going to providing two different services. ASP, it is going to providing two different services. Repeat the options, definitely. ESP do not provide which of these feature? Option 1, source authentication, data integrity, privacy, error control. No, it is wrong. Where are they? It is wrong. Yes, Sophia, it is right. Yes, Sharat, now it is right. It is providing. So authentication has been provided. ESP definitely provides authentication. Data integrity, there should not be any changes. Privacy, yes, it provides. Error control. Error control. Where error control is going, where the place error control is there, the words itself is not there in the entire concept of ESP. Error controls and all. When you go to the ESP concept, you don't find the error control concept itself. So these three things are there. So that is what, go for reverse ordering. So that you want to know. It is an error control. Option is D. And the other one, identify the role of SSL protocol. Identify the role of SSL protocol. So what is that SSL protocol? SSL means what? SSL means what? What SSL does? Secure socket layer, correct, Akshita? Good. Amrita, yes. SSL. What SSL does? SSL is a which provides a secure communication between client to the server. Right? In overall, I'm saying. SSL provides a secure communication between client to the server. Ensures transfer from client to server. Exactly. Data transfer in a secure manner. It ensures data is transferred from client to server in a secure manner. Yeah, right. Based on that, identify the role of SSL protocol. Now you know what does SSL does, the main intention, right? So here the options are being given. Data disclosure. It transmits and broadcasts to the network. The information is not secure. Allows sensitive information such as credit card, social security number, and login credential to be transmitted securely. These are the four options you have. Data disclosure. Second option, it transmits and broadcasts to the network. Third option, the information is not secure. Fourth option, allows sensitive information such as credit card number, social security number, and login credentials to be transmitted securely. Yes, no, right? So already we have been discussed just now. So what is the main intention of this SSL protocol? Allows transmission of data securely. Correct. So allows transmission of data securely. So the data can be anything. It can be credit cards or personal data or login information. It can be anything. Correct? No. Information can be anything. So which is being used to transmit the data securely. That is what the option identify the role of SSL protocol. So along with that SSL protocol, in order to improve, where they have been used, TLS or TTLs have been used in order to transmit the data much more secure. Right. So these are the some of the questions where have been taken, so that definitely it will be very much useful. These questions definitely it will be, and of course only very few of them have been interacted, and hope others also will be going through these steps. Similar type of questions, and as I've been suggested, go through the tables, which are the tables that you are having, diagrams you are having. So which of the following components has been used in so and so round, which has not been used. Such type of questions where will be generally finding out in this type of MCQ questions. Okay. Is there anything that you are having any doubt? You want to ask anything, something like that?
Can you flash those tables, sir? We missed that actually.
It is there in the PPT itself, in secure hash algorithm, where have been included in the PPT, the table it is there. You can download the entire PPT. I think you can able to download that PPT itself.
In which chapter, which unit?
Secure hash function, SHA.
Which unit? Number?
Which unit? I'm not able to get that now. Secure hash functions, secure hash algorithms concepts are there. In that you find. If at all required, I can say the URL. You can send the URL in the the chat box. Just you can copy and download. In the Wikipedia, it is there, that same table. Once you know the table, definitely you can. Shall I paste it in the?
Yeah, please, sir.
Yeah. Please. Excellent. I think you can copy this. Sorry, individually. Sorry. Selected. This is what? Where you can find the entire table. Like that, any diagrams or something like that, definitely it will be very much useful. So, as one of the question you have been identified that in which of the following algorithm these are the steps which have been available, like AES algorithm. That last one where you will be having, if it is 10 rounds, 9 rounds you'll be having, the last round will not be having. Yes, digital certificate authentication. You're having digital certificate. No, you can take like X.509. No, Akshita, we can't explain the descriptive questions revisions, because the descriptive questions already we have been said that these are the units. Actually, we should not tell those units also, Akshita. So we have been said these are the units. When we are discussing the same questions, then what is the use? Entire question paper is with you, because each and every unit may be having 4 to 5 questions only. Correct? No? Based on that, we can't say. So only in overall, we have been said that these are the units. Any other questions that you are having? You are having the doubt? provide the pre-recording not required for these things. Whichever we have been covered, mostly from that only where you'll be getting